Hello everyone. Today I'm going to deliver another lecture. A lecture on first of all I will try to deliver lecture on basic theory on steel structure, and then I will deliver the second portion will be deliver on design of tension member. So let's start the basic theory of steel structure. Let's start. So we know the tension member is truss and compression member is column and connection is joint. So we can know that resisting and strength or capacity will be greater than the applied load. If we consider a building of steel shaded here, if we see the figure, the applied load is here. Applied load is here. It could be dead load, live load, wind load, and the resisting load, the resisting strength and capacity will be greater. That means the resisting will be member capacity, member resistance will be greater than the applied load. Okay, so resistance comes from the materials, which is prime C, and Fy, which is yield strength of column, yield strength of steel, and cross sectional area of the section, which is BDT. And applied load is come from dead load, live load, wind load, earthquake, and demand stress, and so many things. So failure limit. What is the failure limit? Failure limit is a limit, is a condition which is unacceptable to us. Okay, limit, a limit state is a condition beyond which is structural or component cases which is come to end to fulfill the function for is the designed. Okay, so let's see another. There are the three type of limit state. Strength limit, which is flexural, fatigue, shear, settlement, torsion. Okay, so we have found flexure stress equal to MY by I, and shear B equal to BB by IQ, and settlement we have no things, and torsion theta. And fatigue, and another was service limit state, which is buckling, which is pi square EI by L square, KL square, cracking, deflection we know PL by 40 API, or L by 500, and stability, which is resisting divided by service. Okay, special limit, which is unexpectedly occurred in suddenly, it could be accidental cause, which is earthquake and fire explosion and vehicle collision. Earthquake means we know the base shear B equal to ZIC by W, ZIC divided by R into W. Okay, design consideration, we are knowing the some design consideration. The structural should be adequate strength, and reserve strength should be available, and structural design must be provide adequate safety, and important goals, so many things. There are two procedures to design steel structure. One is the allowable strength design, and another one load and resisting factor design. So if you know the allowable strength is coming from material property, we are reducing the material property, and the reduce the design strength. And load resistance, load and resistance factor design, that means we are increasing the load, multiplying 1.2 and 1.3, such as 1.2 dead load, 1.3 live load, in this way. Okay, so maximum in this in our country, in the world, is going to the load and resistance factor design, which is LRFD. Okay, advantage of structure, steel structure as a building, we have seen the steel has a highly height and weight ratio, and it is the proportion uniform, homogeneous, high ductility, and easily reduced, and fabricated easily, quickly fabricated and erect. When effective steel, weather cannot affect, and easier to make condition existing structure. And disadvantage, where the steel is susceptible to corrosion easily corroded, and properties affected by temperature, which is fire or cold. It may be such as a brittle fracture. We know the steel structure is brittle. So we have been seeing the difference between steel and concrete structure. The cost is placed and fabricated in factory. Flexible size and shape are predominant size. We have been seeing the predominant size, and connection is less important in the on the other hand, steel structure connection design is extremely important. Buckling is less important, and steel structure buckling is important. Heavy weighted and light weighted. Construction time is long and construction is very short. Fire resistance is more, by fire resistance is less. This is RC structure is cheaper and steel structure is costlier. Easy to inspect. RC and steel structure is easy to inspect, and on the other hand, concrete is difficult. More safe from territorial attack and less safe for territorial attack. Okay, that's was the difference between RC and steel structure. We can see the how will come the cast iron. We know the iron ore, and then pig iron, then earth iron, then cast iron. So there is some composition of steel structure. We can know the iron is 98%, and carbon is 0.115 to 0.30, copper is 0.20, manganese is 1.03, and phosphorus 0.04%, and silicon 0.28%, and sulfur 0.5%. So we try to use the less than 60 grade use 60 grade steel for the severe earthquake prone, as the ductility high for a lower grade of steel. Okay. So we have been seen two type of shape, which is based on the formation, which is cold form, another is hot form. So what is hot form? Hot form is when iron is melting from fire, and shaping different. It is called hot roll. On the the example is rail line, path of the rail line. It is a hot roll. On the other hand, cold road, which is very thin, very thin, which is tin sheet, we can see, and it can be formed by hammering. Okay. So so this is the master. We have to know then the difference between W and I shape. W shape, the shape of W is a flange will be white. This flange will be white. On the other hand, I shape is flange will be less white. Okay. We can see the shape of steel structure is three types. We get in the white flange shape, which is W shape, and angle shape, L shape, and channel shape, C shape. So we have been shape plus depth plus white. This is the basic sequence, and shape plus depth plus breadth plus thickness, and shape plus depth plus weight. So if we know the W into 14 to 132, the what does mean it? W, we know the white flange shape, which is W shape, and 14 is nothing but is the depth. This is the depth of white flange, and 132 is nothing but the white per feet. This is the main basic of these terms. In the same way, we have seen the angle, which is L shape. If we denoted L 8 into 8 into 1/3, what does mean it? Does mean L means the angle of shape, and 8 first 8 is the width. This is the width or depth in inches, and another 8 is the width or breadth. This is the breadth of the channel angle, and the last one is thickness. This is the most important. This is the thickness, which is 3/4. In the sequentially the channel shape, we know the C 9 into 25. So what does mean it? C is the channel shape, and 9 is the depth. We have been seeing the depth, and the width we are know the width is known is 25 feet pound per feet. This is the width of the channel. So we have to keep in mind this in every job. In most of the job are asking what does mean a W40 into 132. So we have to say that W is a wire channel shape and 40 is a depth, and 132 is a wide pound per feet. In the same way channel and the angle is we have been clarified that. We have been seen the in the earthquake region, the Fu divided by A ultimate divided by yielding ratio greater than 1.25. Okay. So this basic the basic theory has been done. I have said that. Now I'm going to the tension design of the tension member. So at first I'm introducing what is the tension member. We have been seeing the sag rod is tension member. When we design the bridge, we can see the bottom portion is taking the tension member truss cord, and another left splice is we can see when the load is applied it is called tension member. We can see the moment connection between moment connection is tension member. And hanger we can see the man is or what is imposing on the structure, and we have been seeing the tension is taken here. And X base we have been seeing tension and compression is near. When the force is applied from right side, then we can see the tension taken the brass member and compression also. On the superstructure of bridge we have been seeing the cord of is taking the tension member. So you can see another photo is given. I'm taking the online. This is the we can see the beam is taking the tension member. So there is another example you can see here. The tension member is sag rod, purlin, bracing, slenderness, and stable skate. We can see here is a rafter. Rafter tie is a tension member for roof truss. And we've been seeing staggered bridge. The stay cable is tension member, and suspension bridge we have been seeing the tension member. And see we can see suspended bridge building we have been seeing the tension is taken here. And we can see rope purlin system in top court is the sag rod is also tension member. And the bracing we have been seeing the brace frame is tension member. So all are the tension member we have been seeing. Another graph which is taken the at top is taken compression, another one is taken the tension member as the bottom. T means tension. Yes, we can see another building which is the member is taken the tension member. The bridge also taken the tension member. So many things we have been known about tension and compression member. So now start the next slide. To check the tension member or controlling limit of tension member, yield or of the gross section of OIF from connection. We have been seeing yield equal to tension, which we want to fail this portion because we don't want to fail in connection at the joint of the connection in steel structure. In the steel structure, we want to fail the structure away from the connection. Okay, so factor of the effect net area at the connection block shear failure through the bolt. Okay, we have been seeing the block shear which is coming from tearing. And yielding of cross section we have been we are known force equal to stress into area. Tn equal to nominal tensile strength, and Fy yielding strength as is the gross area. We have been how we will calculate this. Okay. So fracture through the bolt or hole, it will be fracture along with bolt or hole. We can see here the Fr and Frg, the the bolt is tearing from the hole. Okay, we have been seeing here another is when Fu divided by ultimate, and we can see the bolt is tearing from the same side. Okay. Here is a Fu divided by Fu and ultimate. And the first one we have been seen f average in f average. So f maximum will be 3 into f average. So you can see here f average will be f maximum into 3. Okay. So where is the net area? The member is section is reduced and the tension is resist. Okay. The member cross sectional area at the connection reduced and the strength of member also reduced depending on the size and loading, and hole are cutting by holes cutting by the punching, sub punching remaining and drilling. Actual hole diameter is governed 1/6 more than the diameter. Bolt cutting causes damage in the molding, and the hole for this region adding 1 divided by 6 and deduction. Okay, so we know the effective hole diameter, the actual hole diameter plus 1 divided by 6. When we see the bolt diameter, then we will be plus 1 by 18. This we have to keep in mind that. So let's see an example. The diameter of bolt plate 1 divided by 4, and the standard hole for 4 divided by 3 divided by 4 inches diameter bolt, and find the net area. So we have to calculate net area of the plate, which is given 1 by 4 into 4, and figure given there. We have been seeing the figure, and the jet section is here, and the standard hole dia for 3 by 4 and standard bolt. The effective hole diameter, we know the actual bolt meter, as the bolt meter is given plus 1 by 8. So actual bolt diameter we have been found 3 by 4 plus 1 by 8. How will get this? We have been seen the question is given 3 by 4 and 1 by 8 is adding. It is coming from this formula. 1 by 8 is as we have used the bolt diameter, and finally found 7 by 8 inches. And effective width of the plate, with plate minus effective hole diameter 4 minus 7 by 8, and the net area will be effective width of plate and thickness. Effective width we have been found there, and plate thickness is given in question in we have been seen 1 by 4, and finally found 0.78 inches square. This was the answer. So let's see where is the staggered hole. When hole we have been seen hole are not in vertically in the same line, then we can say the staggered hole. When a hole is greater than 1, then we can say the staggered hole. And when the failure zone will be occurred more than one line, then that will be staggered hole. So this criteria must be full, then we can see the staggered hole. So how we'll calculate the net area of staggered hole? So there is nothing but this in previous will be same dimension, but one portion will be added, which is s square divided by 4g. So how see? We know the W area, which is WN, which is width, minus n is how many holes is occurred, and dia of hole we know we have taken the dia of hole plus 1 by 6 plus 1 by 6. If we taken the bolt dia of bolt meter, then we will calculate by diameter plus 1 by 8. So there is no issues, and plus s square divided by 4g. This is the new term is coming when the staggered holes. We have been seeing the staggered hole which is not sequentially in vertically, and plate thickness. Okay, so we can see how we'll get the area if we calculate the width and thickness, then we'll get the area. Okay, so these are the width and thickness. So s square by 4g, how we'll get this? This is the term correction length. Correction length we can call s square divided by 4g. What is the s? S is nothing but S is the nothing but the space between when along the load. Suppose we are taking the load this direction, so S will be the first this bolt and this bolt, between the spacing between these two bolt along the load. In the same way, I will calculate the G. The G will be nothing but it will be perpendicular of the load. If we taking the load is this way, then the distance will be this hole between the perpendicular uh, distance. Okay, so let's see another example, then we will be clearly understand. Determine the minimum net area of the plate. Figure is given below. Assume the diameter is given 15 by 16 inches. So we've been seen the four hole is given 1 A, B, C, D, and plate is given 1 by 4 inches. We've been seen here, and this is the 12 inches which is width, and the first hole distance is 4 inches, and 2 by half which is 2.5 inches, and 2 by half which is 2.5 inches. So so we have to calculate the minimum net area. Okay, so we calculate, we know the area which is W, which is mean W in this is the width and thickness, plate thickness. So width and deduct will be a number of hole, n is number of hole or bolt, and dia of hole, and plus 1 by 6 plus s square plus s square plus 4c. As we have been seen, this is the staggered, because the wall hole are not vertically same or horizontally same. That's why we are taking we are considering this figure is staggered. Okay, so let's see how we'll calculate the path AD. So this is the first path which is AD. We have been we are trying to see in here the first path. Okay, let's see how we'll cut. This is the AD. First is 12. 12 is this is the width of 12, and how many hole we have know the hole is 2, and 15. What is the dia? Dia is given here 15 by 16, and 1 plus 6. 1 plus 6 is the constant. We have been seen here already 1 divided by 6. When we will use the hole, then will be 1 by 6. When we use the bolt, then we will use the 1 by 8. So you have to keep in mind it. And yes, there is no yes, as we have been seen the before the explaining what is the yes. Here is there is no s, as we have been seen the same vertical line. That's why you have been used, and the plate thickness is 1 by 4 is given here. 1 by 4 is given the figure, and found 2.50. And another path we have been seen ABD, which is ABD. Okay, so let's calculate this path ABD. ABD, I will get 12 minus 3. 3 is a whole number of how many hole? 1, 2, 3. And dia of hole we have been known the 15 by 16 is given in question, and 1 by 16 is a constant. We have been seen if we use the hole, then 1 by 16, and if you use the bolt, then will be 1 by 8. That's why we will use 16. And now how we'll calculate the s square by s square force. This is the most important. Okay, so we have been seeing the two portion. This is 1 and this is 2. So at first we will calculate AB. This is the AB. The AB will be yes, will be this distance. This distance we can say. So we have found this distance which is 2 into 1 by 8, which is 1.25, 1.25, and 4 into s, 4 into g. What will be g? G is nothing but is a particle distance. So we are known 2 into 2 by 1 by 2, which is 2.5. Which is 2.5. And in this way, now we'll calculate this this portion B and D, and in the same way s square is same 2.10, and 4 into g. G is change. We have been seeing the g is given here 4 in g. Okay, and found 4.13, and remain path B, C, D. So we've been seeing B, C, D, and this path we have been changed the another path. We can see the lots of path is we can calculate B, C, and D. In the same way we have calculated and found first path AD is 2.5, and second is BD 2.43, and another one is very less, which is 2.46. So which are the minimum? We have been seeing the minimum is 2.43, so the minimum will be control. That's why the minimum path, the failure will be occurred in minimum path. That's why we will consider A, B, C, which this path will be we will consider. Okay, let's see another example. Determine the minimum net area. The same question of plate is figure below. Assume the bolt diameter is given and plate thickness is 7 or 5 by 8. We can see here area equal to width. We are knowing the given the width, and into how many bolt, and dia of bolt is given. In this case, dia of bolt is given. Another we have been seen in the previous, the hole is hole number of hole is given, and that's why you will use the 1 by 8. And as we have been seeing the staggered, that's why you will use s square by 4g and of plate thickness. So path A, B, C. So at first we have been calculate A, B, C, and let's see A, B, C. Okay, 10 number of hole is 1, and 7 by 8 we know the die of bolt is given 7 by 8, and 1 by 8 is a constant, and there is no this is the actually vertical we have been taken. That's why it will be s will be 0, and found 5.625. And second one, we have been given ABFG. Okay, ABFG, this is the double dotted line we have calculated in this path, and 10 is given on the 2, 3 and 2. This is the total 10, and found minus 2 2 is nothing but 2 is the how many hole is bolt or hole in this path. We have been seen 2, and the die of bolt is given 7 by 8, and 1 plus 8 is a constant, and yes, there is at AB, in the AB path there is no s. On the other hand, we have seen the FB or BF is there is a another s length, which is 3 in given in question is 3, and 3 into g 0 s is given, and g is 3 also 3, and remain FG there is no s and g. That's why this portion will be also 0, and 5 by 8 is the plate thickness, and found 5.469. In the same way, we can calculate path BDE. We have been seen B DBFG, another path, and calculating and all this path, and we have been seeing the 3 1 2 3 hole is given here, and found 5.313. And in this three results, we have been seeing the minimum actually is found 5.313 is governed the DBF path. So this part is very critical for failure zoning. Okay, we have been seeing another effective net area. We have been seeing in net area will be A into U into area. What is the U? Why we need the net area? When the load is does not passing to the CG, then we have to calculate the net area. Okay, so that's net area U equal to 1 minus CG minus L. How will get the CG? It's a loading line and connection line. Distance between loading line and connection line. L. What is the L? L is the correction line. Okay, let's see. Here is another one, shear lock. The non-uniform stress in wide plate or element or roll section when the tension load is applied on uniform is referred as a shear lock. Okay, determine the X bar. How will calculate the X bar? So we'll connect the X bar is coming from the connection plate section, which is LCWR to the CG. So you can see the X bar it is taken from plate connection plate to the desired CG. You can see X bar, another X bar. In this case, you can see X2 bar into X1 bar. This is the two CG have been taken. Okay, how we'll get the CG when we consider the bending this portion, then we'll take this portion only CG. Okay. So connection length we have been known. Then what is the connection length? Connection length is the maximum length between two holes. So suppose this is the three hole. How will get the maximum load, maximum length? So we have been seeing the maximum distance between two hole is we can say the connection length is here. So another connection length we can see the maximum distance, and this way, and in this case we have been taking the maximum distance. So we can see here the wild connection. This is a picture which is a longitudinal weld and load transfer is comes, and longitudinal weld plus transfers. This is the and another case we can see only transverse weld is load transmitted, and another we can see the longitudinal two longitudinal side load is transplanted. So these are the three cases we can see here. Is donated in our picture. So you can see another determine the reduction factor U to be applied to the compute to the effective net area which is given W into 14 into 82 section connection by plate at its two flanges. Figure shown is that there are three bolt along with the each connection which W x prime is given and T WT is given and BF equal to given and D is given. You can see here the three type of bolt is given here, which is 10.13 inches, and X bar is given, and W section is given also 14 into 82. So solution will be given here. Reduction factor U equal to 1 minus X bar into L. X bar is given in question which is 1.39, and L is the length. We have been seeing the maximum length 3 into 3, and which is found 0.77 reduction factor. So according to the SCI table CK7, we have been seeing PF equal to greater than 2/3 D, and found U equal to 0.90. If B equal to less than 2/3 into D, then we will use U equal to 0.85. So our BF equal to 10, and D we have been found 14.31, and which is 9.81. So BF is greater than 9.81. So we will use U equal to 0.90. Okay, so 0.90 will be used, and reduction factor could be 0.90. These are the answer. So you can see another graph how many paths we can the section will be the section will be collapsed. So at first we can see this section this type of occurred, as we have been seen the two as we have been seeing the tearing will be occurred this two type of bolt or hole. And then second option we have been seeing the three bolt or hole is given here, and the failure mode will be like this. And then if the total bolt we have been seen 1 2 3 4 5 6 7 8 9 10. So 10 we at first we have been 10, and we have been seen the two type, that's why 2 divided by 10, and second one will be a fifth. Why? Because 2 and this 3 and if we adding this all three sum, then we will get the 5 divided by 10. In the same way, then we will 5 2 and 3 will be 5, and then we will adding and another 2, that will be 7. So that's why we will use the 7 in this part. We have used 7 t divided by 10, and last one we have been seeing the only t. Okay. So here is some vital formula for tension member. Now we are going to the last portion of this lecture, design of the tension member. How we will design the tension member. So let's start, and this is the last topic on this lecture. So we have been seeing the tension member is there is some limit. We have been seeing yielding, fracture, and block shear. So if we calculate the in LRFD, then the formula will be Tn equal to 0.90 Fy into Ag. As a basic formula, we know the force equal to stress into area, and we have used the some multiplication factor, which is 0.90 for LRFD. And the same way as D will be 0.60, and we have been taking the some remarks. And for fracture, we have been seeing the stress into AE and multiply 0.70. And the same way on the other hand, you can see the ASD method, stress into AE, but the multiplication factor is 0.50. So I will get the AE. We have been seeing U into A, and U is nothing but 1 minus x bar divided by L. And I will get the N L down the this formula W into whole number into pi of whole 1 by 8 into staggered square plus 4G and plate thickness. And block, how will get the block shear, and 0.50 FUX plus 0.60, and another formula will be used as per ASD. So block shear is very important on the compared to the yielding and fracture. So let's see how we'll calculate. This is our first example. So let's read. Determine the service load capacity of the tension for capacity in tension for L section is given 4 into 4 into half, and the F52 grade F52 grade 50 is still connected with 7 by 8 and diameter bolt in the standard hole is shown. The hole is shown is good. Assume the live load to be 3 times of the dead load and neglect the block shear. So we are not calculating the block shear. Okay. So we have been seen here the all things are given here. If we calculate if we see the on the left side, then we will or front side, then we can see that this type of this type of figure will be arised. Okay, so we have been seeing the distance of from this point to this point 1 into 1 by 5 into this portion to this portion 1 into 1 by 4, and this portion to this portion 1 into 1 by 4. So load is applied in the perpendicular of the W, and all the distance between the all hole is 2 inches square, as we have been seen in figure. Okay, so another we can see the thickness of channel is 1/2, and given this dimension is 4 inches square, and this is the 5.5 inches square. Okay, let's see. At first is given the channel section L section L into 6 into 4 into half. Then we'll go to when L into 4 into 5. Then we'll calculate AG and X bar from AISC menu. I will get we just go to the AISC menu manual and find out L into 4 into 5. So we can see L into 4 into half. This is the portion. Then in this way we can if we found this, then we will consider we'll taking the area, which is we have been found 4.75. Then we have taken 4.75, and X bar also we are taking the similarly X bar. This is the Y bar, and we'll go to the next table. This is the X bar, which is 0.981. So in this way we will taking this from AISC manual. I'm not showing again and again. I will take in this value from AISC manual. Okay, keep in mind it. So for section 1, so we have been seeing this is the section 1. A into W into N into bolt into 1 plus 8 into S square divided by 4G into PT. W equal to 4. How will get the 4? This is the total width is 4, as we know. 2 into 1.04 into 2 plus 2 into 1.4 into 1.4, and the total is 4. Total is given the we have been seen the total is given 4. So Now we'll see how we'll calculate this. We are deducting total we have been seen here, and bolt is given 7 by 8 into 1 plus 8 into, there is no stagger, that's why 0, and plate thickness is given half. So plate thickness is given half, the last signal is half, as we have clarified and found 4.21. And we have taken the another example here, as we have been seen here, the another technique, which is for Lg into n into bolt into s square divided by 4g, and Lg equal to 4.75. So 4.75, then minus deduct this value and found 4.25. And for section BB, we have been seen the BB, this is the BB section is staggered, and W equal to 4 into 6, we have been seeing the 4 into 6 minus half, we are reducing minus half, as it is overlapping, and is 2. To why we have used 2? Because we have been seeing the 2 bolt or 2 bolt, that's why we are using n value is 2, and bolt dia we are knowing 7 by 8 and 1 plus 8, and as we have been seeing, this is the value of as the 2, this is the axis value between the horizontal, and the vertical portion we have been seen 4 into 2.25. 2.25 is the vertical portion we have been seen here, 2 into 1 by 4, which is 2.25, and found 1.39. So we have been found two type of n, which is 4.29 and 3.19, 3.97. So 3.97 is less, so we are taking the 3.97. So now we will calculate the u, which is 1 minus x bar into L. How will get the x bar? We are taking from the AIC mineral 0.971 and found 0.93. So I, how will be I will be n into u, and multiply this with n, and found 3.91. Now as 5 F572 grade 50 steel, we know the 50 grade steel Fi will be 50, and Fu ultimate will be 1.5 into 60, which is 65 KSI. Now we'll calculate the by ASD method. So we know the 0.60 Fi into S, putting this value found here. For fracture, we are using 0.550 into Fu into A, and found 125. Now we are found two type of load, and we are taking the small load, which is 1 to 3.8. Now we will calculate live load, which live load equal to 3 times of dead load. So now we know the dead load plus live load 123, and live load we are taking the 3 times, and in this way I found the dead load is 30.9 kips, and live load equal to, we are knowing the 3 times, and 92.7 kip. Now we will calculate the same math in LRFD. Thus we are changing this multiplication factor or reduction factor. We have been used 9.90 FIAG and found 213. For fracture for fracture we will use 0.70 and found 178.5. And in this way we are taking the small portion with 213 and found one other one is 185. So we will take the 185. Then the same remaining dead load equal to 3 times of live load equal to 3 times of live load, and we know the dead load plus live load is found 175, and in this way we found dead load and live load we have been taken 397. So if we clarify that in ASD by ASD method, we have been found the live load is 92.7. On the other hand, we have been used the dead load LRFD method. We have been found the live load is 3139.2. So that's why we will use in practically we will use the LRFD method rather than ASD. Okay, so yes, we have been seeing the maximum the bigger value is found LRFD compared to the ASD. Okay, so let's see another example. The select the an uh, unequal new equal leg, uh, unequal leg ankle tension member, maybe it was spelling mistake, tension member and 50 feet long to the resist service load, service dead load is given 50 kip and the service live load is 70 kip use 36 steel which is fu is given 36 and fy is given 36 and fu is 58 and the connection of figure given below it shall be consider the gases plate using 8 knots and 3 by 4 net and dia bolt is row is given below. Neglect the block shear, so we have not calculated the block shear failure mode. Use the LRFD method. So as we know the we have to calculate the size as is given the reversible load as length and dab load, live load, fy, fu and dia is given. So factor load 1.2 dead plus 1.6 live load is given there and we know the yielding equal to p equal to phi equal to Pn is Fy into force equal to stress into area and putting this value and area is 14.75. In the for fracture we have been use P equal to phi L to P equal to stress into AI and putting this value and found AI equal to 0.54. So now we will use AI equal to mu equal to n and found AN equal to 4.25. Now we will use as equal to an as we have been found an equal to how many bolt is we have been seen here the two bolts in pathway we are considering one pathway and dia bolt take is given 3 by 4 and 1 by 4 as we are considering the bolt and plate thickness. This is the most important how we'll get the plate thickness. It is coming from the short technique which is L divided by R is less than 300. So 300 is coming to the bottom the L and R is in the right section. So L we have been found 15 is given we know the 15 is given the lawn and we are multiplying 12 in convert to the inches and found 0.60. So what does mean is 0.60. 0.60 is the less than 3 by 4. 3 by 4 is means 0.70. That's why we are taking the assumption which is the value of R and the plate thickness is 0.60, but we are taking the close to the 0.60 which is 0.70. Okay, so in this way we found the AG and the yielding we have been from yielding AG we have been found 4.75 and the fracture we have been found 5.74. So we have been seen the bigger value we are taking, so bigger value 5.74 we will consider. When AG is 5.74 then we will select now we'll select the section L for then we will select L section 4 C or L in L 6 into 4 into 5.8 which is 625 from AIC menu. How we'll get? We just go to the this menu and we'll see how the value is as equal to 0.75 and now we'll go to the 175. Okay, this is the 74. Where is the value of AG? Okay, AG. Okay, this is the 78. So as we have been found the when we are deducting value of AG is 0.75. Now we'll taking the from AIC manual we'll take the value which is greater than 0.75. So 0.75 we are selecting here as 0.78. So this is the L4 L6 into 4 into 5 into 8 5 into each which is the value of A which is greater than 0.75 or close to 0.74. So that's why we will selecting this value. Okay, so the chosen L value here and AG is 0.6 5.86 which is greater than 0.75. Okay, now t is given 5 by 8 and r minimum is 0.8.5. So all the data is given here as we've been seen, 0.58 and we point 8 point 859 point 859 859 r minimum is taken from the AIC manual. Now we'll check again and equal to AG into both distances, putting all the will found and AG equal to and SE equal to similarly, and yielding into found in 170 and fracture equal to found in the same way. So we know the ultimate we have been found 160, which is greater than 154. 154 is found in previously. This is the 154, which is the 1.2 dead load plus 1.6 live load. So you can see this angle is okay. So this angle is okay. So this is our final selection. So now before we going to the leaving, then we are considering the stiffness design. So L by R into 300 and we are taking L divided by 300 and 1.60. So our minimum we have been chosen here, our minimum 0.859 and we have been found 0.60. So 0.855 is greater than 0.60, so this is okay. So our selected angle L 6, 4 and 5, this is our answer, and we can use this angle for this information or for this information basis. Okay, so let's see another example is here. From the following table, select, this is the table we have been seeing the AISC manual. This table is taken from AISC manual. Following table and select the highest channel section. Use the tension member, which is 16 feet long, and to resist the service dead load 50 kept and service live load is 150, and use 36 steel, which is FU 58. The tension member shall be connected as a gasket plate using 10 notch and 7 by 8 inches bolt, which standard hole is 2 row and figure is given below. Neglect the block shear, so we will not consider the block shear. We are taking the another class on block shear and mode, and following AIC LRFD principle, and assume U is given 0.70. So and we have to check L divided by R less than 250. So let's see here, the factor load 1.2 dead load plus 1. Live load is given 300, and yielding we are using this formula, yielding and found AG equal to 9.32, and for fracture we have been using AG and found 0.6.9. So now we putting this value SE and AG and found and which is 9.86. Now AG equal to N into bolt into die, putting all this value and found 11.29 inches square. So we have found 2AG, which is 9.26 and 11.29, but we will use the bigger value which is 11.29. Then we will consider another how we will get the PT value or plate load at 0.716. So we are just reverse calculation. We have been taking L by R 200 less than 250 and R equal to L divided by 250. L equal to given here the 16 feet, and we are multiplying with 12 and taking into inches, and we have been seen here which is 0.768, and we are taking the less value 761 which is 0.716, and this is our assumption, and we are taking in our intentionally, where as you are taking bigger or lesser is not a big deal, but we are taking the less value of PT value and found AG, okay, which is 11.29. So when we take in the AG value which is 11.29, then we'll select the channel. So we'll go to the AISC manual which is here. So we are taking 11.29. So we are taking the bigger value 11.29, which is 14.7. So we are choosing 14.7, and if we as this is the lower value, and we are taking the bigger value of AG, as we are taking the 14.7. now we are getting the all the parameter, which is thickness. We have found the wire thickness and flange thickness, and in the second portion x bar we have been found and y bar we are also found. So we are taking rx 5.24. So we are seeing here rx, here is rx 5.24. We are taking here from here ry is also 0.865. Ry here is a 0.86, ry 86. Okay, ry, where is ry? Let's give me 1 second. Rx ry, where is rx? Here is ry. Okay, okay. 0.865. So this is the found, and thickness we have been found, and wire thickness we also found. So these are the taken from ASC manual. Now we'll chosen 50 and as E been found and T found and R minimum found. This two value are found. Now we'll putting this value and found and putting this value for AIE, and for yielding we have been found 461 and fracture for 444. So we have been seen 444 is greater than 300. 300 is nothing but this is the factor load, is 1.2 dead plus 1.6. So this we can say, oh, okay. So another check we have to consider the stiffness design, which is L by R is greater than 15 and found 0.785. So we have seen 0.785 and we are taking the R minimum, which is 0.86. We are taking here R minimum 0.865. So we can see the 0.865 is greater than our calculated value. So it is okay. So our last selected selected channel is C15 into 5. So this is our answer. So we can see another example. This might be last example in our classes. So from the following table we have been select the light 250 long unequal leg shear tension member of to resist the surface dead load 50 and live load 70. Use 36, which is F equal to 58. Get the compression figure is filled on yellow. It shall be connected to the gasket plate using 3 by 4 inches diameter and 2 rows assume U equal to given. So we have to know calculate and prepare L by R equal to less than and 300. Use LRFD method to neglect proxy. So we will not calculate proxy. So this chart is given from AIC in our question. So factor load we 1 plus 2 plus 2 dead plus 1.6 live load, which is 142. For welding APU equal to, we have been used the 142 and 5.90 FU and AG found 0.4.3. For fracture we have been found PU equal to taken on 42 and found 0.75 and 5 and AE 3.26 and AE equal to, we are putting this value and found AN equal to 4.1. And we're calculating as equal to and we have been found 4.1 equal to number of bolt we have been seen here as a we have taken his here 2 and bolt 4 by 3 is given in question. So there is no worried about this. And PT, where this is the important how we'll take that plate thickness PT. We are calculating the back calculation L by 4 L by R divided by R into less than 300 and L we have been found that 20 feet is given in question, and taking value which is 0.86, which is 0.80, but we are taking the greater value which is 0.86. This is the plate thickness. So this is the coming from the assumption calculation and found AG equal to 5.6. So two type of AG we have been found, which is 4.38. Here is a 4.38 and another one is a 5.8. So we will take the 5.8. Now we'll go to the ASC menu which are greater than 5.8. So AG we have been 5.8. So we must be remember that which are greater than 5.8. 5.6. So we've been seen here the 5.6 is AG. We've been seen here 5.6. So this is the 5.31. We've been taking L's 6 into 4 into 9 by 16. 9 by 16. So this is the edge is a 5.31. Now these are the very close to, so that's why we are taking this selection this way. If we selection this way, then we will taking the rx value. We have been rx how much, rs 1.9. So we have been seeing x-axis here, and this is r, so 1.9 is rx. In the same way, we don't need ry or rz, but we are taking here. Now we'll check how we'll get this value, and putting all this value, we are just plate thickness we have been found 9 by 8, which is 0.861. So we are putting this value here, and found in the we are calculating back calculation, and found the fracture. We found fracture for 132. For yielding, we have been found 172. So we're taking consider the minimum load 132. So we have found 132. So 132 is resisting. On the other hand, applied to hormone. So this is not okay. So we have to chosen another angle. So yeah, I have intentionally wrong this, because we are taking our calculated as equal to 5.6, but we are taking as equal to 5.31. That's why the section has failed. So we have to choose a section which is greater than ag value is greater than 5.6. So if we chose the 5.6, if we chose this value, then the section will be passed, which is L64 into 3 by 4. If we chose this value, then the section will be passed. As we have taking the ag value is intentionally, we have chosen the another the less than the desired value. That's the have to chosen another angle. Okay, to this lecture is ended. I think the long lecture has provided. So if you just ignore this basic if you want, but you cannot solve the design the tension member without skipping if you skip the basic theory of digital success. So that's all from me. If you have any question, then let me know. I will try to solve your question. Thank you everyone. Thank you.